This is a demonstration of different kinds of radio interference. It's a pretty straightforward setup, and we'll look at each different component and discuss them. First, of course, we have the radio receiver, which is acting as our victim. I'm going to turn up the volume, and you can hear the signal that it's receiving. That signal is coming from this signal generator over here, which is set to 49 megahertz, which is what the radio is tuned to, and the box on top of it is our modulation source, and I'm going to vary that so you can hear it. Okay, so that's the modulation source, that's the signal we're trying to listen to. And now what we're going to do is to listen to different kinds of interference. And one of them is called broadband interference. That comes from this guy right here. And that's broadband interference. Down here. That's broadband interference because we can tune the radio to a different frequency and we're still going to hear it. We can't get away from it. So I'm going to turn the impulse generator back on, and I'm going to tune the radio to a different frequency. You can still hear it. Okay, enough of listening to that. Now what we're going to do is we're going to listen to narrowband CW type interference, the kind you might get from a microprocessor clock. And what I have here is another signal generator which is tuned to 1 megahertz, and that would be that's 1/49th of the tune frequency, which means that if you look closely, we're looking at the square wave output, which means that the 49th harmonic of this signal is going to fall in band to our radio receiver. And let's see what happens when we turn it on. And all of a sudden, we hear nothing. Okay? I'm going to turn the radio way up, and so we can see when I turn the RF off here on the CW source, you can hear it. And when we turn it on, we can't. That's called quieting. Now what's really interesting about this is what happens if I turn off the actual COMM signal. Okay. Now I'm going to turn off the microprocessor clock. And that's what we get. Now notice what happened there. We had the background noise of the radio unsquelched, and it when we actually had this simulated interfering signal on, as it is right now, we can't hear it at all. But when we turn the signal off, the interfering signal off, we get it right back. This is known as quieting, and if you were to be listening to a radio receiver and you tuned through the frequencies and you suddenly came across this, you would say, boy, this is a really clean, this radio is really sensitive here. And in fact, it's not clear at all, because watch what happens here. I'm going to turn it on. Like a noise. I turn my signal back on. That's the COMM signal I'm listening to, and now I'm going to turn this interference signal, the CW signal that we couldn't hear before that made the radio sound quieter. I'm going to turn it on again, and now we basically lost our signal. So the point is here is that if you were just listening to background noise on a radio and you had a interfering source like this, a microprocessor clock, you might not realize at all that you had an interfering signal, because it actually made the radio sound better than when it wasn't there.